Yeah, I'm going to go through this presentation, but we're going to spend a lot of time on this little guy right here, which is simply an IoT connected little M0 or M3 device with a DHT temperature and humidity sensor on it, and of course the appropriate wiring to make it work. And so that's what we're going to spend most of the time on. But I end up using these kinds of things for a lot of stuff. Here's an IoT connected device that's actually cellular based, and this is LTE based device. Here's one here that's also an LTE device, but it has an H bridge connected to it, so it does motor control and servo control. I use these things for a lot of different stuff. This one here is actually controls a set of LED strands, and there's an additional chip here to actually do the line level converter, because this is a 3.3 volt logic and this is a 5 volt logic on the strands. So I need to have some oomph there to convert the logic levels. So that's a logic level converter. It's actually a bus driver. And that would connect into something like this. This is a roll of dot star LEDs, and then could drive the individual pixel colors and everything on top of all of that. So I have a number of uses for these kinds of things. And I'm going to kind of go over this basic temperature and humidity sensor thing for today. Let's get into it. So first of all, my name's John Pellant. I think I'm still a technical specialist in West Central Florida, but my call is W1JP. I live in Inglewood, Florida. That's where I am today. And I'm an electrical engineer, and I spend most of my time doing software stuff than I do hardware stuff these days. But I do love to tinker in the firmware and embedded Linux fields, as you'll see here as we go forward. So this is the agenda for today. We're going to go through what is Internet of Things. We're going to talk about what's the thing side, cloud networking, and then I'm going to use Google Application Script to drive a lot of what we're doing here. And I'm really big fan of Google Application Script, and we'll talk about that. Introduce you some JavaScript, and then we'll talk about other options than the one I'm just talking about today. So that's what we're up to today. All right, so what is IoT? Well, here's a couple definitions for you. I grabbed one from Wikipedia, but really what you're doing is you're taking a sensor, a capability, a device, something that is normally wired, if you would, and you're adding essentially wireless networking to it, and you're adding a CPU that can orchestrate things, and you're adding an infrastructure that allows you to communicate that thing and tie it into the internet and then be consumed by other things within the internet. These days, why is this so popular? Why is it happening now? That's because these CPUs, for 69 cents, we can get a CPU that's more powerful than the $120 million Apollo program computer. And the Wi-Fi chips and connectivity are down around $1 now, so you can get these things fairly cheaply. As you could probably see if you played with the Espressif chips that are in the $5 to $9 range that you're paying for. So, and people are still making money selling it. So that's why you're seeing smart refrigerator, smart everything, because it's really attainable now to add these things into your product offering. So it's not just a thing, it's a system, right? Like I said, it contains both a smart Wi-Fi enabled thing, the network that you're going to be using to carry that information, the cloud services to tie that information to consumable access or consumable things, and then something, playing, or once it's there, it can go anywhere. It can go to intelligent assistants, or Alexa, Google Voice, browser, smartphones, pretty much anything at that point in time, right? So this is what I was showing you earlier. What you see on the left-hand side, this is actually a particle device. It's called a particle photon. It's a under 20 bucks. And what you're seeing here is a DHT22, which is a I2C communicated device, I believe, or is it certain? No, I think this is the DHT. So it's I squared I2C devices. And I can see from the pull-up resistor that that's probably true. We're going to be talking to this. This has temperature and humidity sensing on it. And we're going to be getting that information off, and we're going to be sharing it with the internet where it can be consumed. All right, what is a particle photon? Again, this is an older device. The current ones that changed footprint a little bit. They're now using the feather configuration of that Adafruit came up with out of New York, so that they can be used with standard layouts and stuff that plug into the feather footprint. But this is the one I've put together for this thing. It's essentially an STM32, 120 megahertz ARM Cortex-M3. It's got a Broadcom Wi-Fi chip on it, and it has a megabit of flash and 128 kilobyte of RAM. Not a lot, but as you see, we don't really need much when we're talking to sensors and things like that. It's even possible to host web pages in here for configuration and things like that, even in the 128K of RAM. So it's still quite powerful. It's, as I said, it's got the Wi-Fi chip, which is, this is a BGN Wi-Fi. The newer devices, of course, have more capable Wi-Fi chips. At the base of this, we're running a free real-time operating system. So this is an open source OS, fairly lightweight, low level, provides threading and stuff like that. If you're familiar with Arduinos, it supports the same type of Arduino wiring APIs, as well as the ability to bootstrap and load off the air, which is really key. You can make really easy to prototype things. You can update stuff right off the air and everything. If you're interested in the data sheet, here's the data sheet on that product, and it'll show you where, you can see all the things that are on it, all the peripheral types and things like that. It's actually quite a capable little chip, and this is like I said, this is a deprecated one. This has been deprecated. Back to my, I don't know how to get back to my. Sorry, I don't normally use Zoom. I'm a Google Meet guy. I don't know how to move this thing so I can. You know what? I haven't been sharing, have I? I apologize for that. Somebody should have said something to me on the phone. But let me just go back a couple slides. Again, this is the one that explains the board I showed you earlier. Also, this is the photon particle with the specs on it that I was showing you. The data sheet, you can link on this and get your access to things and everything like that. This is one thing to know is that these devices are 3.3 volts. And if you look at the data sheet, they cannot provide or sink much amperage. So they don't have a lot of strength to them. And that's fairly typical of these M0, M3, all these chips, even a Raspberry Pi, even a BeagleBone Black, all those kinds of things don't have the drive capability. So I strongly suggest that you use bus drivers and level shifters and things like that, because just converting to a bus driver now, that can put out 60 to 100 milliamps per line. And you get the ability to with the weak drivers on these other chips, you can run into a lot of things if you don't have access to an oscilloscope, things like that, to see that you're having noisy, weak signals and things like that. The other thing we're using here is we're using a, oops, that's a typo. It's a DHT22, not an SHT22. And this is one of those that does I²C. So when we talk about cloud services, there's a number of different things, a way people talk to environments in the cloud. Probably the most popular is RESTful communications. REST stands for representational state transfer. It essentially allows you to have verbs, create, read, update, delete type of thing, which the equivalent to that is get, post, put, and delete in HTTP. So we're using those HTTP verbs to do something, to handle them on the back end of this. The other thing is that when we send data back and forth, most RESTful applications use JSON. Some use XML, and some might use some other things, but most RESTful APIs consume and produce JSON. What is JSON? JSON stands for JavaScript Object Notation, and I'll show you a little bit about that when we get into the demo. All right, so how does this thing work, right? Well, there's three things that this thing can do. It can have a variable, a function, or a webhook. If we look at each of these individually, I have to move this thing again. At this controller thing that's in my way. All right, if we look at this, the particle cloud here, we can look at a variable. So what happens is that this device will read that, get a temperature and humidity or whatever it's getting from the sensor, and then populate variables in memory on this device. These variables are then exposed or shared with the particle cloud. So anytime there's a change in the variable, in this case, this is the particle cloud. You publish that to the particle cloud. Once that's variables published to the cloud, then you can use a regular HTTP GET on the device with the device ID and just the name of that variable, temperature, and it'll respond with that temperature. I'll show you this in a minute. Functions, on the other hand, are something that get exposed to the call, and then you can call a function with an HTTP post command and the name of the function. For example, in this thing, I'm setting the period, which is the sampling period for the temperature, to 600 seconds. So every 10 minutes, it's going to check the temperature and publish that to the web. And we'll talk about that in the next slide here. The third thing is something called webhooks. Webhooks allow you to integrate with other web consumable. It's a protocol for cloud-to-cloud communication, essentially. So what we do is we publish a measurement, which is a webhook, and we name that, and we publish what we're publishing to that, and then whenever we have an event or change that variable, we can push that to the cloud, and then whatever webhooks are connected to that will automatically get called with that change of information. So for this case, we're publishing a measurement every, if the period was 10 minutes, we're going to publish that every 10 minutes to the cloud, and then the webhooks will call. In this case, I've got a Google spreadsheet that actually has a post webhook that, so every time the Google Cloud gets hit with this post, it's going to update that measurement in the spreadsheet. All right, so excuse me 1 second. All right, so like I said, we're using Google Application Script here. And before Google Application Script is essentially, if you're familiar with Google, if you have a Google account, you're familiar possibly with all the tools and stuff on you. You have Google Drive, you have Google Documents, Google Slides. This is a Google slide right here. Google Sheets, of course, Gmail, Maps. There's a number of tools that are out there. As a matter of fact, if we look at, let me just, if we just hit this Google nine buttons up here, these are all the apps that are scriptable that you can actually talk to with that application, or with this Google application script. Excuse me. But these things are very, very powerful. In my day jobs, I actually use these a lot to do some very powerful things because it's quite easy to do. For example, in this company, we did our payroll and pay stub generation all from this, all from Google application script. It's really easy to do ETL type things because you can go grab data via REST operations, bring it in, massage it with all the power of spreadsheets, do whatever you need to do, and then put them back into some other application. Or as well, it's great for reporting. I can go grab a set of information from anything Exposure Web, and I use it a lot for even automation. For example, I can go grab HRIS data, changes, onboarding, and automate a lot of the work that would normally be done by human beings, via these mechanisms. I'm going to just check the chat here because there's 2 questions, which probably. Okay, yeah, thanks. The slides. I'll try to keep this up now so I can launch. So what is Google application script is actually written, uses JavaScript. Many of you know what JavaScript is, but for those of you who don't, it's actually quite an old language. It's been, it was created by Netscape, as part of the language of the web for automating browsers. It's part of the specifications for web pages and combination of HTML, JavaScript, and CSS is what drives the bulk of the web technologies these days. For those of you that follow JavaScript, there are major changes made in 2015. JavaScript is actually controlled by its real name in its specification name is ECMAScript, but colloquially you can replace ECMAScript with JavaScript because ECMAScript is just hard to say and ugly, in my opinion. So, but in 2015, ECMAScript came out with a new release called ECMAScript 6, ES6, and they added a number of things to this. And the power of JavaScript became much. It just exploded from the pigeonhole as being a web or browser language to be able to do stuff in the back office and on the back end. Node.js came out of this, and Raspberry Pi, BeagleBones, they all have Node or Node-RED, or the ability to run Node on it. And then the cloud environments jump right on this bandwagon as well by AWS Lambda, Google Cloud Functions, Cloud Functions, and Azure Functions are all written in, can all be written in ES6. And ES6 now supports many different programming styles. Procedural, it used to be just purely a procedural language. Now it supports functional paradigm and asynchronous and multi-threaded functional paradigms. And declarative models. For those of you that have some familiarity with some languages, functional type languages are really are used quite often for back-end RESTful type things because functional programming paradigm means I'm calling something without effect. they're modal and work very well over the web because they don't require state and they don't require solid connections. So you can have connections that you connect to it, run that function. That function's atomic, and then it gives you back results that you can then move and forward and do some other things. So the functional paradigms was key aspect of a lot of things done in ES6. We're now at about ES10, and like I said, it's even supporting even more and more, even more and more things, right? So, let's look at a little bit of what modern JavaScript looks like. If you're familiar with the old JavaScript, everything was a var, a variable. And so an array would look something like this third line down here. I can use a pointer, can't I? Use the pointers. I want to use a oh, well. Guess I don't really know how to use that. Like I said, I don't use Zoom too much. But the big changes to an ES6 are, while var is still supported, it's discouraged. We want to use let, which makes a mutable variable, which I can set a string to and then change it. And if you notice that JavaScript supports both quote types for strings. So if I want to use quotes and strings, I can use the other one to denote a string, literal. The other thing it provides, which is the most safest thing that it came out with, was the things called constants. Pi is now immutable, and pi can't be reassigned or it's going to throw an error. This was causing all kinds of JavaScript errors to begin with because everything was mutable, and that can lead to some nasty things. And then we have a thing called an object, which you're familiar with Python and other languages. It's like a dictionary, so it's got a key value pairs. As well as an object in JavaScript can also have methods and executable functions and all the other things that come with object orientation. And then how do you print to the screen? Well, it's console log is historic from the web, but there's also print.io functions and things like that where you can write to streams, string streams and file streams and whatever kind of streams there are. There's a couple different ways now to strings concatenate, so you can add them together. So I can say hello object name, which in this case is, I guess I don't have my name in here. So in this case, whoops. Name is John, right? So in that case, it's going to say hello John, W1JP, because that's what the string contains. The newer way to do this now is with what's called formatted strings. And formatted strings substitute whatever's in the $ bracket, end bracket, with the Java expression, and it evaluates the Java expression and puts that into the string right there. And this is what you'll see need to do almost entirely these days. The other thing that if an object has a toString conversion to it, it can pretty much convert itself to a string, so you can concatenate almost any object to it as long as it's it supports that toString trait, to borrow a Rust term. All right, on the Google Cloud side, what's happening on with this Google application script, I'm going to show in a moment. The webhook, remember, is sending a post. That post is sending a JSON payload. That JSON is going to have key values like an object or a dictionary, and it's going to have a temperature, and it's going to have a value for that temperature, and humidity. It's going to have a value for that humidity, and we'll have a timestamp of when that sample was taken. and it's going to call the add new temperature endpoint in the Google Sheet for the Google Sheet to update. So let's take a look at some things. Okay, demo time. All right. Where am I going? Did I lose? Oh, you know what? I think let me just escape out of this because it's in this one here. Sorry, guys. I said I'm getting. So I'm pausing this here, and then I'm going to go show you some things, some other things on here. So let's talk about particle. As you can see, I got a bunch of these devices in the particle cloud. The one we're working with today is called W1JP IoT, and of course that's the one I showed you earlier. It's sitting right here in my, and it's connected to a battery, so it's talking everything over Wi-Fi on my Wi-Fi here at home. So if I click into this device, you can see that I got a bunch of things here. I've got the ID of the device, the name of the device, what is its status? It's currently online. What operating system is being run on there? What is the type of the device is a photon, when the last handshake was, the serial number of the device, and all those kinds of things, right? I can ping the device to see if it's active, and it says the device is online and connected. So I can make sure it's there. I can check the signals strength, which when I click on that, the signal here, I don't know if you can see it, but it's doing a red, white, and blue ball on the light on the device here, so you can see which one this is if you have dozens of them sitting on your desk, which I sometimes do. And you can see that I have strong Wi-Fi signal. My round trip time is not really fast, but it's 11. It's gives you an idea of what you can and can't do around these things. Typically 1 second things are going to be hard to do. I'm using 32 kilobytes of RAM, and I'm not running it against any of my rate limits at the moment. What you see here is everything that was published to the cloud. And so here's the functions. I have a sample measurement, set period, temperature, status, humidity, sample period, and things like that. So if I call these variables, I can go get their value right off the device. So let's go check the temperature right now. It's 25.7 degrees Celsius. The status of that device is 0, which means that it's not publishing right now. It's just sitting there waiting for commands. I can get the humidity, which is 43.7%. And the current sample period is going to be 0 because we're not sampling. And if I get a status message, I'm going to get essentially the JSON string that gets published here. I can ask for a sample measurement, which is going to call that function, which comes back with this. Here's the JSON package of what gets sent from this event publish, and which has all this information and timestamp. So that's what's going on the device. If you want to see the code, we don't have time to go into necessarily all the code here. Generally, I can break this down into, but all the code that's running on this device fits in 170 lines of JavaScript. And all I do is define the pin on which I'm talking. I define a maximum or minimum sample, minimum size of the sample. So I won't do it anything closer than 5 seconds. So we'll just cache anything that's less than 5 seconds. A bunch of global variables here. I have the DHT function that reads the sensor, and that's I'm talking to this pin 3 thing, and it's using essentially the same stuff that you'd see in wiring. So it sets the pin mode to an output. It does a digital write on that on the pin to drive it low. It sends the start signal, which is the start signal. It waits 1 second, and then it reads, it pulls it high, and then we'll go back to the pull-up resistor on that thing, and then read the information off of it. So that's what the pulse in does here. It's reading the pulses in, which then I'll calculate that. Excuse me. I can calculate the period, which is what that's holding, or calculate that. Then I do a little bit of error checking, the 3 second time. I'm checking for errors. I read in the bits, and I have the checksum. So this is, I won't get into the details of how that does. I'd spend too much time. But then after we're done, I take all those bits that I collected off the bus there, and I calculate temperature and humidity from those values. And then I grab the timestamp, which is just grabbing the time from now. And then that's it. Just if you're familiar with Arduino, you have the standard setup. This is where I'm setting the time format to ISO 8601, which is the time and date format that's used for spreadsheets. Or at least that's what Google Sheets supports, so does Excel. The pin mode, initial pin mode on the pin I'm talking on, and then I publish these variables, the temperature, status, humidity, and sample period, and status message, which I walked you through before. And then I also publish the 2 functions that can be called by the cloud, and then the webhook response to be able to subscribe to the webhook that I'm publishing. Then I have a thing called get measurement JSON, which generates the JSON back up here. So I generate that JSON response. And then I have a continuous loop that I have a tick. If my sample period is greater than 0, I'm going to sample if that tick is, at this above the sample rate. Otherwise, I'm just going to ignore this. So right now, this thing's sitting in this endless loop doing nothing. I could put it to sleep for a certain period of time and wake it up, and all those kinds of things that you can do with a M3 or M0 that you would expect to do with a microcontroller. If I do have a sampling period and my tick is above that sampling period, then I'm going to go ahead and sample it and then read the sensor, and then I'm going to publish that JSON to the cloud, and that's all this thing does. So let's get into the spreadsheet. So you should be seeing my spreadsheet on the device here, or on the screen here. And it's a very simple spreadsheet. I have a timestamp, a degrees Celsius, degrees Fahrenheit, and humidity. But it looks like a standard spreadsheet for all intents and purposes. Now, I don't know how many of you have played with Google Sheets. There's things here, this tab called extensions. And if I look at extensions, you see a bunch of different things you can do. AppSheet is a low-code environment, low-code, no-code environment where you can create applications essentially out of a spreadsheet using low-no code. But I happen to know JavaScript, so I'm going to use AppScript because I like code. So I'll open this extension, and boom, this brings me into the environment for this spreadsheet. If we look at what we have here, we're saying, okay, this is a spreadsheet app script. The container is the temperature demo, which is this, right? And here's created last thing. Here's its error rate, use rate, stuff like that. How many users? You know, a little data on it. And that's, you know, kind of this overview information. Editor is the code. Triggers, not using them here, but you could set triggers for these things so they can run, you know, by different event types. So if I add a trigger, I can choose, okay, what function to run, which deployment of this application, and you know, when is it by time, you know, and you can essentially create cron jobs or some other events. You could have a web hook that you could expose to come in here and do an event and things like that. So there's all kinds of interesting things you can do with triggers, just not using them in this script. Here is the execution environment. So you can see my last thing was to clear the sheet before I went and tested it, make sure everything worked before this. And I now just cleared that sheet. So I can see, you know, what happened and when. That's the log of, that took 0.93 seconds to clear the sheet. And then I have a bunch of things down here. What time zone? Galapagos. I'll do that some other time. What Java engine am I running? I'm running the Chrome 8 V8 runtime. This is the script ID. And then I have a number of script properties. This is being recorded, so I'm not going to go into them because it's got my private information here for things like my authorization sign-ins, things like that, for the particle cloud. But let's go into what this is doing. Let's go back to the temperature thing. What happens when this thing runs? Let's look at the first piece of code. There's this function here called onOpen. So when this temperature demo sheet opens, it runs this script. And what you see I'm doing is creating a new menu item called scripts. And I add these three things to that scripts. And you can see that right here. So this thing here, the scripts menu item I created. And as you see, I have a clear log, a fetch measurement, and a set logging period. So let's see how these work. If I click the fetch measurement, I'm going to run out. I just want to talk to this device sitting right next to me here, and it went and grabbed the temperature, which is 25.2 or 77 degrees Fahrenheit. The humidity is 44.3, and here's the timestamp that it grabbed for that device. I can go get another one, fetch another measurement. And as you can see, it was 23 seconds later when I did this, and you know, some things have changed a little bit. It's getting warmer. That's pretty cool, just that. But the other thing you have here is the ability to change the behavior of the spread and add capabilities to a spreadsheet as well. So when I want to set the logging period, this is going to open up a sidebar over here. This is just a regular HTML page that I provide to set the logging period. Note that 0 will stop the logging, but I'm going to start logging here, but I'm going to set a 5-second period. So I'm going to hit set period. And as you can see now, every 5 seconds, I'm going to be getting information. So what's actually happening here is that if you recall, the particle thing is going to be publishing these events every 5 seconds. So you see this event, hook response, which is, and it's sending measurement, right? So you're seeing these measurement followed by a hook response, which is coming back from the webhook, which is hitting the Google Cloud, letting you know that that was successful or not. If I look at one of these hook responses, you see the status is okay, which means that the Google Sheet consumed it and returned an okay status. So we'll look at those things here in a second. let's go back to this. So as you can see, I'm getting a lot of good data here. If I want to stop it now, I can change that logging period back to 0. And it will stop the device. And that'll be the last one that we get here until I change the logging period again. And I can close this sidebar or do whatever I want. So as you can see, there's a lot of power. And again, we're not talking that many lines of code here. So let's walk through the code that makes this happen. It's a little bit more than the code that makes the sensor happen. But as you can see, this is pretty powerful stuff. I originally did this in 2019. I've added a couple things to it. I updated to the DHT instead of the SHT. And then most recently, like today, it was just in Celsius and humidity. I added the Fahrenheit thing that I just did today. So I always, you're going to see a style of the way I like to code. I'm not saying everybody needs a code like I do. This was originally written in ES5. I've updated some of it to ES6, but I wouldn't probably even use the same structure today as I would back in 19, since this thing now supports ES6, 7, and parts of 8. So that's the on-open, which added these scripts capabilities to the spreadsheet. Then I have this web app here. This is the usage for the web app. So if I have any incorrect or malformed requests, I'll come back with a usage and let whoever's calling it know that they're screwing up and here's what I'm expecting. I use this technique a lot. This is a logger that I will use, and then I have a debug flag. If the debug's, I don't set the debug's true. So this will log if debug is true. If debug's not true, it'll just ignore this stuff. So then I have two functions called return usage, which is results of the call. If you screw up, I'll return usage. If you do if I can do what you're requesting of me and I understand everything, then I'm going to return OK, which is what you could see we got here was the hook response data OK, status OK. That's coming back from this call right here. All right, status OK right there. So this function here is called logit, which is going to take the data received off the web. But let's get back to the web post command first. So here's the web service. You've got the get command. So I have a function here called doGet, which gets called whenever this web service gets called with a HTTP get. And then I don't support get. So all I do is support a post. So this is where I'm going to just return the usage. No, you got to do a post to me, and here's what I'm expecting. So if I have a post, it's going to call my do post with the request information. So the first thing I need to do is parse the JSON body of the request, which is request post data contents. And then that's going to be my post. And then I am going to parse that post data. And data should now be an object with temperature, humidity, and timestamp. And so I check to make sure that happened correctly. Because if there's no temperature data in that, I'm going to say, boom, there's an error here. I was expecting all this, and then I'm going to return usage, right? You screwed up. You didn't give me the right thing. Otherwise, if it works correctly, we have what we need. Then I'm just going to call this logit function with the data and return the OK. And for anything else that doesn't happen, I'm going to return the usage thing. So logit, what does it do? It's the meat of talking to the spreadsheet. Where's logit? I can make this stuff bigger too. I probably should have done that. I apologize, guys, for not making this code bigger. But where's my logit? There it is. Here's my logit function. And so this is the API that's available to you. I call the spreadsheet app, which I get the active spreadsheet that I'm currently in, the active sheet, which if you look on the bottom here, all of these are sheets, and there is only one. So this is the active sheet that I'm using. And then from the active sheet, I create a new row array and I start pushing it to it. I grab the timestamp and push it to it. I grab the temperature, which is in Celsius. I push to it. Then I take that temperature, I convert it to Fahrenheit by keep in mind that data temperature is a string as we get it from JSON originally. It didn't convert it to a number. But I do that here. I convert it to a number. Then I can use math on it. So here's the equation to convert to Fahrenheit. And then I push that onto the row. And then I push the humidity onto the row. Now I have an append row. So I'm going to take that active sheet. And I'm just going to append row to that spreadsheet. And that's what you see it doing all the time when we come back here. So if I do a fetch measurement, that's going to append a new row with that new measurement on it, right? I have one other function here called clear sheet, which gets all of the which essentially just clears all of the cells underneath the header and footer. And then that's all that's in this code, main part of it here. There's the particle stuff, and this is what's calling the functions. So this is the get measurement thing that gets called from when I fetch a measurement. And this is all I'm doing here is making essentially a HTTP request. It's a post with JSON payload that I'm just calling the get measurement endpoint on my call. That's what the URL fetch does. And then I can get the results. I parse that JSON response, and then I call log it with that result, which is essentially the measurement JSON string that I got back from that call. And that's calling the particle cloud. And then set logging period. This again is going to do a post. It's going to call the set period endpoint. It's going to hand it in the options, which is my argument equals period, which is that's 5 seconds or 600 seconds or whatever the period is that I passed to this thing. And then I'm creating logs of all this stuff too. And then this is an interesting one. This shows this sidebar. So when I called when I called the function to set the period, it opened an HTML sidebar for me. That's what this does. So it uses the HTML service to do that. And the HTML file is right here, set logging period HTML. I'll open that in a second. I set the title of that window. I set its width. And then I call the get UI to open it. So what is that HTML? So this is this very simple HTML. So this is regular, what you'll see in the body here is the heading 1 set logging period, the instructions, a label for the period with an input box of type text, and then a button that calls set period, and a button that calls essentially telling the it's telling the spreadsheet to close this window when I'm done. And this is how you call scripts. From here, I can call the script in the main script area, which is running that set logging period that I showed you earlier. I know that's a little bit of time. You can do many things with these. Matter of fact, here's another one that you can see as scripts. I'm going to go to the template here, the template page. This is the template page. So I have a script here called add new log, which will generate a new log page for me. Then I can do a QRZ lookup. And so I can take a call sign like W1JP. It will go ahead and fetch this information from QRZ's database. And then if I hit add, it'll go ahead and add the timestamp, the call, who called, lat long, position of where they're at, and grid square. Why do I use that? Because there's other techniques. I'm going to run out of time here, but just to show you some other things we can do with all these things. This is running hamlib. So I have essentially a Python Flask, no, Python Falcon, sorry. What thing here? I was going to show this in the afternoon, but I'm not in a position with Zoom to do that because it's in the other room, so I'm not going to be able to do that, show this one. But this is showing essentially how you can get rig control and a Raspberry Pi here in the background. I'm just running a rig control daemon on there. So I can talk to a rig and get the frequency of things here. So I can talk to the Node.js box set and get a frequency off the radio. And then that can also get logged into these logs, right? Rig server here is essentially provides a WebSocket. And so in these spreadsheets, I can call a WebSocket. Once I'm able to use hamlib, now I can do things like, okay, I can automatically populate the frequency. I've got another one here that does that, but I'm running out of time. We add frequency to this, and then plus now using rotor control, I can actually calculate the bearing to and distance from the call sign, and then point the rotor, to that location as well. So that's all can be done with these things. I can and on COC, I can look up. I can add him to the log. Let's do K9XV. Let's add Tom to the log. Yeah. So that's all using QRZ's REST implementation. It's using not JSON, but it uses XML. But that's a discussion for another time, I guess. So, getting back to the presentation here, what alternatives are there to Particle? Particle gives you actually a lot for very little. So I like to use it, but I could also use if this then that, IFTTT. So you can go explore that. Lots of people publish open ends, webhooks there that I can consume. For example, I could ask Alexa to check the temperature, right? So I can have an Alexa skill that has a webhook that Alexa can then go fetch the temperature from this device and read it. Things like that I can do from here. MQTT is quite old. It's a open message queuing telemetry transport system that was used. It's simple, text-based. It runs in even smaller platforms. I've done this on PIC-8s. The problem with MQTT, in my opinion, is that there's literally no security. It's essentially a telnet protocol, and so you can't use TLS on it. And it also requires a broker. So you have to either have an open source broker that you install and run yourself, paying for your own hardware, or you can use a third party or commercial one. Here's an example on Adafruit.io. But there's also Google Cloud IoT, Azure IoT, AWS IoT, the IoT offerings from just about every cloud vendor there is. So here's one for you. If you want this presentation, grab a picture of this or scan the QR code there. Once you get this presentation, you can have access then to all of these links. The particle electronics, the data sheet for the photon I used, the different devices that I used, where to find information on Google application script, IFTTT documentation, Adafruit IO, MQTT, Oasis spec, Adafruit's MQTT. I think this link's busted actually. But you can find it at the IoT. And some more things, if you're interested more on JavaScript, W3 Schools is a good source. Here's the Mozilla reference for JavaScript. Node.js, which I love using. I use it for a lot of things. I just chose to do the other thing for this afternoon in Python just because I know I wanted an excuse to talk about Python with this community as well. Both Python and JavaScript are great ways to do this. Most of the things you can do in JavaScript on these devices, you can do in Python, except for particle. Thank you. That's all I have. So